Hello guys, welcome to my YouTube channel. Today we will learn about Arduino UNO, how we can use it, how we can program it, and how we can connect different hardware devices to it. Let's begin with the basic introduction. Arduino UNO is a good choice to interface with electronic devices. I am sure you must have some basic knowledge of electronics. As you can see on the screen that this is a small battery of 3 volts and this is 3 volts LED. As we know, the battery has two terminals, positive and negative. The LEDs have the same polarity, positive terminal and negative terminal, which runs in DC supply, where we always have to check the voltage range before we use it, or else it will damage the LED or any other devices which is not in the suitable voltage range. Here we will connect the positive and negative terminals to the LED, and by doing this the current is flowing through the LED and the LED is now bright. In Arduino UNO, we can connect our hardware devices such as sensors, LED, memory cards, speaker. By connecting them, we can command it to work as we want. So how it will understand our commands? For this we have to program it using our PC or mobile phone. As we know, we have different languages to speak. Arduino UNO has a programming language called C or C++. This is our Arduino R3 board, which is best choice for the beginners. Here we have two power inputs. This one is 9 to 12 volt input and this one is 5 volts USB input. Here you can connect your type AB cable to your PC or into your mobile phone using OTG to connect this board. As you can see, this is the main part of our board, that is a microcontroller, which is known as 8MEGA328P. For programming, it has 32 kilobyte of flash memory to store your code, which is done by a software called Arduino IDE, Integrated Development Environment. An application can program Arduino UNO by connecting them to your PC or your mobile phone. Let's gain some technical knowledge about this board. This is our microcontroller IC. These are our pins. Here on the left side we got analog pins and power pins, and at the right side we got digital pins here. Analog pins are for the analog input, which can take in range of 0 to 5 volts and convert it to digital value, which is called ADC, analog to digital converter. In power pins we have VIN pin, where we can give 9 to 12 volts input. At 5 volts pin we can have 5 volts input or output, and at 3v3 pin we can have 3.3 volts output. And for the all power pins, the voltage reference ground pin is GND here commonly. In Arduino UNO we have 20 GPIOs, means general purpose input output pins, in which there are 6 analog pins, A0 to A5. It can be used as digital pins also. At the right side we can see there is a pin called ARF, which is analog reference pin. It is used to set a voltage level for the analog input, at which level we are giving the inputs at analog pins. Here is the digital pins D0 to D13. In digital we know digital means 0 or 1, which is similar to off or on. These pins can turn on or off the connected device with our Arduino UNO board using programming. There are two parameters in programming: low parameter for 0 and high low parameter for 1. As same in programming we can use 0, 1 instead of low or high. In some digital pins you can see a small symbol similar to signal. These pins can generate PWM signals, pulse width modulation. This is 16 MHz oscillator which provides clock frequency to our microcontroller for its running tasks. This is a USB to serial converter consists of CH340 IC which converts USB signal to UART signal which is understandable by our microcontroller. This is the reset button of the controller which restarts the controller. By pressing it, it stops the current program and starts from the beginning. There is an inbuilt LED which is internally connected to D13 and ground pin which is used for testing purposes. There are also two other LEDs which are connected with D0 and D1 pins which are TX and RX pins. TX means transmitter and RX means receiver. Using these pins on the serial monitor, we can read or we can write the data, and the data is ongoing on these two pins between microcontroller and our PC, which is used for mainly debugging purposes for checking values. Now we will connect our Arduino UNO board to our PC using this USB type A to type B cable. Connect it to 5V input and the other with USB into your PC. This is our Arduino IDE application. As you can see, there are two predefined functions, and this is our programming area where we will write the code. On menu bar, go to Tools, then go to Board, and you have to install the Arduino AVR boards using Board Manager. Then you have to find the Arduino UNO here, then select it. Now you have to select the COM port. Here you can see Arduino UNO is visible. Select it. After setting this, we have to write our code here. So first we will write the LED blink code. Here you can see on the board, this one is our LED which is connected with D13. So here we will define our LED using define function. So hashtag define LED 13. So now our LED is defined on the D13 pin. The variable name is LED and it is defined as an integer number 13. In setup function, we will declare our LED as an output device because LED is an output device which will give output in light form. There is a function called pin mode where we have to tell the pin and its mode. The pin is LED here at 13 and the mode is output which we have to write in caps. After that, don't forget a semicolon. We can see a void loop and a void setup. These are two functions where void setup only runs the code inside it only for one time in the beginning, and void loop function will run the code inside it for the infinite times. There is a function called digital bright where we can define the pin and its level. By this, we can change the voltage level on the defined pin, which is LED for now. In first argument of the function, we write LED, then the level high or low. Low means 0 volt, ground will be on that pin, and high means 5 volts will be on that pin. If the LED is connected with ground and the another pin with D13, then you have to give 5 volts means high to turn it on, and if it is connected with 5 volts and D13, then you have to give low means 0 volts to turn it on. Remember to connect a resistor with the LED to protect it. In our board there is an inbuilt resistor with this LED, so no worries. Now we will turn on the LED first, then we have to put some delay because when the LED will turn on or off, we cannot see it because this board has 16 MHz of frequency, which is too fast. So here I have added 1000 millisecond of delay, which means 1 second, and you can change it as you want. Then after the delay, we will turn off the LED using digital bright function. Now we will low the LED. so it will turn off, and also don't forget a semicolon. Now again we will add 1 second delay here using the delay function. So here our first code is ready to blink our LED. As you can see, there are two buttons, verify and upload, where verify button will compile the whole code and will return errors if there is any error in your code. So here we will directly click on the upload button that will compile the whole code and upload to our board. As you can see, our code is compiled and uploaded to the board. Now you can see the LED is blinking every 1 second. You can also connect an external LED on pin 13 with ground using a resistor. So congratulations, you have completed your first LED blinking code. Thank you for watching till the end. Bye bye.